Exercise 12.2, Problem 7, Discussion. Let's read the problem. Two dice are rolled simultaneously. Find the probability that the sum of the numbers on the faces is neither divisible by 3 nor by 4. So what's given here? Two dice. And we are asked to find the sum of the numbers on the faces neither divisible by 3 nor by 4. It's a little tricky problem, okay? But now what we need to do is, let's find, anyway, nor or is very, it leads to the same addition theorem of probability. So let's take the event A of getting the sum to be 3 and B be 4. And what will be A intersection B? That's the sum of the numbers on the faces divisible by 3 and 4. Okay. So using the addition theorem, find the probability of A union B. That is probability of the sum being divisible by 3 or by 4. But we want nor, right? Neither. After that, finally, all you need to do is subtract that probability of A union B from 1. So 1 minus probability of A union B is probability of A union B the whole complement. This is nothing but A union B the whole complement. Okay. So let me repeat. So let's define the event A as the sum being divisible by 3. B is sum being divisible by 4. A intersection B is divisible by 3 and 4. Using these three values, calculate the probability of A union B. And the required answer is neither, right? Neither divisible nor by 4. Neither divisible by 3 nor 4. That is probability of A union B the whole complement. That is nothing but 1 minus probability of A union B. Earlier we had calculated probability of A union B, from which we can calculate the value of 1 minus probability of A union B, which gives us the required value. Okay. So let's get going. So what's given? Two dice rolled simultaneously. Two dice. Okay. We need to find probability that the sum of the numbers on the faces is neither divisible by 3 nor by 4. When they say the sum of the numbers, let's say the first die gives you 1 and the second die gives you 3. The sum of the numbers on the faces is 1 plus 3. That is what they mean. So 1 plus 3 is 4. But they want to have select items, outcomes where the sum is divisible by 3 or by 4. Okay. So that is how this will be calculated. What's the formula? The same addition theorem. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. So what will be the first step? Did you guess? List the sample space. List the sample space for rolling a die twice and find n of s. Next, let's define event A by the event, let A be the event getting the sum of numbers in the faces divisible by 3. B the event of getting the sum of numbers on the face divisible by 4. I'm sorry, I made a mistake here. So this is 3, so this is 4. This is a problem of cutting and pasting actually. Okay, so divisible by 4. Right. And what will be A intersection B? A intersection B will be getting the sum is divisible by 3 and 4. Okay. So now we have defined all the 3. So find the outcomes. List the outcomes. We have the sample space. So sample space is all the outcomes. So select the outcomes which is pertaining to event A. Select the outcomes which is pertaining to B. Select the outcomes which is pertaining to A and B. So then after that find n of A, n of B and n of A intersection B. Once you find that, find the probability of A using n of A divided by n of S. Similarly find the probability of B and probability of A intersection B. Once that is done, then you can substitute all these values and get the probability of A union B. What is probability of A union B? Probability of A or B. What is A here? Probability of the sum being divisible by 3 or by 4. Right? So now you calculate that because this is known, and this is known. So which means this can be calculated. But what are we asked? We are asked to calculate probability of the sum neither divisible by 3 or 4. That is nothing but A union B the whole complement. And what is probability of A union B, the complement? That is 1 minus probability of A union B. In step 5, we calculated probability of A union B. So from which you can calculate this value. Okay. So the probability of the sum is neither divisible by 3 or 4 is probability of A union B whole complement, and that is 1 minus probability of A union B. We have just calculated it, substituted, you'll be able to get the value. Okay, so this neither and all these things, first find the not. If you remember exercise 12.1 also, not a white color. So find probability of white and subtract that value from 1. That will give you not white. So this negative ones, find the positive statement is positive event and subtract that value from 1 will give you the negative probability of the negative event. Okay, so these are negative events. Events. So probability of selecting a number. So this probability of the sum being 3 is positive. Probability of the sum not being 3 is negative. So find the probability of the sum being 3 and subtract that one from 1 will give you the probability of selecting the sum not being 3. Okay, so that is how this problem needs to be worked. So let's get going with the solution. So what is the solution? First step is listing the sample space. So sample space is given here. The trick is fix the first digit as 1 and the first dice is 1. The second dice can give you 1, 2, 3, 4, 5, 6. So you get 6 outcomes. Now go to the next row where we are fixing the outcome of the first dice is 2, because first dice also can have 1, 2, 3, 4, 5, 6. That is all. The first die moves here vertically and the second die moves horizontally. So that is how we will be able to get the total sample space. So here you took the samples first die showing 1. The next case is the first die giving you 2. Okay, and in which case the second die can give you 1, 2, 3, goes on like this. Now keep changing the first die to 3, first die to 4, 5 and 6. Then you'll be able to list the entire sample space. I'll put a tree diagram in the next version. Probably that will make life little easier. Okay. So n of s is how many? 1, 2, 3, 4, 5, 6. And how many rows are there? 1, 2, 3, 4, 5, 6. So 6 into 6, 36 rows. Other way of calculating, the first die can give you 6 outcomes, right? It can give you 1 or it can give you 2 or 3 or 4 or 5 or 6. 6 outcomes. Similarly, the second die also can give you 6 outcomes. So the total outcome will be 6 into 6, 36 outcomes. Right. Now sample space is done. We'll have to select. Let the A be the event of getting the sum of numbers divisible by 3. So we'll have to select the outcomes which is favorable to event A. That is, what is it? The sum is divisible by 3. Now you see, select 1 plus 1, 2, not divisible by 3. 1 plus 2, 3, yes, this is divisible by 3. This is 4, right? It's not divisible. 5, not divisible. 6, yes. 1 plus 6, 7, no. 2 plus 1, 3, yes. 2, 4, no. 5, no. 6, yes. Like this, you'll have to go through each and every sample space, each and every outcome, and select the items which is divisible by 3, right? That is what is already done here. 1, 2, 1, 5, 2, 1, 2, 4, 3, 3, 3, 6, 4, 2, 4, 5, 5, 1, 5, 4, 6, 3 and 6, 6. You add anything, 4 plus 2, 6. 6 is divisible by 3. 5 plus 1, 6, divisible by 3. So this is all the outcome which is favorable to A in the sample space. Now how many items are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 outcomes. What is the probability of A? N of A divided by N of S. N of A is 12. N of S is 36. So 12 divided by 36. And don't simplify it, keep it there as it is. Next, let's B be the event of getting the sum of numbers divisible by 4. You repeat the same process. Now let's go through. 1, 3, yes, this will get selected, right? Because this is divisible by 4. Then 2, 2, this is selected. Then 2, 6 will be selected. Okay. 3, 1 will get selected because 3 plus 1 is 4, divisible by 4. And then 3, 5 will get selected, right? 5 plus 3 is 8. and that is divisible by 4. Like that, you go through each and every item, and I have listed it for you. These are the outcomes which is favorable for B, which is nothing but divisible by 4. Now you check anything. 3 plus 1 is 4, divisible by 4. 4 plus 4 is 8, 8 is divisible by 4. 6 plus 2 is 8, 8 is divisible by 4. So all these items are divisible by 4. So how many items are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 items are there. 9 outcomes are there. Right? So probability of B is 9 divided by 36. Now, next step is to calculate probability of A intersection B. That is the outcome. The sum is divisible by 3 as well as 4. So instead of going to the sample space, you better go to the one of this A or B, whichever is smaller. Because it is A, it will be in A as well as B, right? So there is no point going to the sample space. But you see A has got 12 items, B has got 9 items. So let's go to B. Now it has to be divisible by 3 and 4. This is all divisible by 4. So all you need to check is whether these numbers are divisible by 3. That is, sum is divisible by 3. Because it's already defined for 4, right? So 3 plus 1 is 4. It's divisible by 4 but not divisible by 3. This is again 4. It's not divisible by 3. This is 8. Not divisible by 3. 3 plus 1 is 4. Not divisible by 3. 5 plus 3, 8. No. 4 plus 4, 8. No. 5 plus 3, 8. No. 6 plus 2, 8. No. 6 plus 6, 12. 12 is divisible by 3. And it's also divisible by 4. So probability, n, the item or outcome which is favorable for A and B is 6 and 6. And n of A intersection B is only one item is there. So one outcome is there. So it's only 1. And probability of A intersection B is n of A intersection B divided by n of S, that is 1 by 36. Now you can calculate probability of A union B. That is probability of A plus probability of B minus probability of A intersection B. This we know, this we know, this we know. Substitute all these values. Probability of A, we calculated it to be 12 by 36. Probability of B is 9 by 36. And probability of A intersection B is 1 by 36. Substitute all these values. So it will become 12 plus 9, 21, 21 minus 1, 20 by 36. But what is this? Probability of the sum being divisible by 3 or 4. It's divisible. But what we want? Not divisible. So that is probability of A union B, the whole complement. What is that? That is 1 minus probability of A union B. Probability, this is positive, this is negative. But that's what we want. So find the positive and subtract the value from 1. It will give you the negative value, right? So that is 1 minus 20 by 36. That is 16 by 36. 36 into 1 is 36. 36 minus 20 is 16. And this 4 will go 4 times. 4 will go 9 times. So the value is 4 by 9. Thus, the probability of getting the sum of numbers on the faces neither divisible by 3 nor by 4 is 4 by 9. If they ask it divisible by 3 and 4 means this is the answer. If they say not divisible, subtract this value from 1. Then you get 16 by 36, which is 4 by 9. Okay. So I hope I made it clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.